So Chris, in this question, what are Superman's X and Y components? Now, how we do this question is, this is basically basic trigonometry. So for example, uh, let me put my X and Y axis at this point. Uh, at this point. Have you understood?
Yes, sir.
So this point is basically this point. Is it making sense?
Yes, sir.
Now, what are Superman's X and Y components? So they have given this angle to us, 30 degree. And what they have told us is that this distance is 100 meter. Is it making sense?
Yes, sir.
See,
Yes.
Chris? Yeah. This is basically a right triangle like this. You would have done this in trigonometry. Is it making sense?
Yes, sir.
So, for example, this point O is now this point O. This Superman is this Superman. And this point P is this point P. Is it making sense?
Yes, sir.
Now, what when they ask you about the X and Y component, what basically they are asking you is this. They are asking you this, the magnitude of this, and the magnitude of this. Is it making sense?
Yes, sir.
Uh, this is the X component, and this is the Y component. Now, one point that you will need to understand is that actually this Y component would be this this part. Is it making sense?
Yes, sir.
This part. So, how this becomes useful for us? Now, just try to understand how this figure becomes useful for us. Now, when I'll be doing vectors. So, for example, force is a vector that we have discussed. Velocity is a vector. Displacement is a vector. Is it making sense?
Yes, sir.
So, what they'll say is the question that will come, and once we understand this, what is the question that we'll be able to solve? Would be when we do the force numericals, they'll have a question like this. What they'll say is that there is a force, this force, it has, let us say, it is at 30 degree with x-axis. It has a magnitude of 100 Newton. Chris, is it making sense?
Yes, sir.
Can you see the similarities in these three figures?
Yes, sir.
Now, the question that they will ask when these force question come, they will ask you, uh, what are the uh, x component and y component of the force. Is it making sense? See, what
Yes.
we need to understand is basically what we need to understand is that if I have a vector, if I have any vector, now that vector can be any vector. It can be a force, it can be a velocity, it can be a displacement, it can be momentum, it can be anything. So all the vectors, any vector that I have, I would be able to crack that vector. Of course, I can crack it in XYZ plane also, in three dimensional also, but that is something that you will do it in class 11th. But here, only we are cracking this vector which is in the XY plane, and we are cracking it into two parts. One would be this part, which will be the X component, and the other component would be Fy. Chris, is it making sense?
Yes, sir.
So basically, when they are asking me to do a question like this, they are slowly taking me on that path where the vector has to be resolved into x component and y component. Is it making sense?
Yes, sir.
Now, how? Let us come back to the question that we were discussing. I have this magnitude of 100 meters, yeah, and this is 30 degree. Now, using basic trigonometry, what I know is that SP upon 100 would be equal to sine 30. Chris, have you understood?
Yes, sir.
Therefore, SP would be equal to 100 sine 30. Can you tell me what is 100 sine 30? Can you use a calculator and tell me?
50.
I'm sorry,
50.
50. So
Yes, sir.
this will be 50. Sorry, this will be 50. So this part SP is 50. Is it making sense? And similarly, this part OP upon 100 would be equal to cos 30. Is it making sense? So OP would be equal to cos 30 into 100. Can you tell me what is the value of this cos 30 into 100? Yeah, Chris, are you calculating?
So, yes, sir. My internet connection went off. What do I tell?
Cos 30 into 100. Cos 30 into 100.
Yes, sir. So, 86.60.
Shabash. So now, using basic trigonometry, I can make out that 100 meter can be resolved into 50 meter and 86.6 meter. Chris, is it making sense till now?
Yes, sir.
Now, when we come to our question, let us look at our question again now. That when they are asking me to resolve the Superman's components in x and y axis, now this 100 meter that I have, in terms of x component, in terms of x component, this would be uh, 86.6 meters. Is it making sense, Chris?
Yes, sir.
But the issue is that this 50 meter would be facing downwards. This would be facing downward. Is it making sense?
Yes, sir.
So this is where Superman is. Now Superman component in terms of x and y axis will become 86.6 comma minus 50. Is it making sense?
Yes, sir. But why minus 50?
Yeah, by minus 50 because see this is where Superman is.
Yes, sir.
Till here 86.6 is positive. Is it making sense?
Yes, sir.
But this part is negative. Is it making sense?
Yes, sir.
That is why this has become 86.5 minus 50. Is it making sense?
Yes, sir.
Now, another thing that I want to explain using this concept is that, if I was given a force of 100 Newton, now let me erase all this and try to understand this example in terms of forces. So, for example, if I had a force of 100 Newton, and that force of 100 Newton had to be resolved into its x component and y component. Is it making sense,
Yes,
Chris?
sir.
See, what we need to understand is that the force is a vector for a momentum. Is it making sense?
Yes, sir.
So they can give us any vector and they can ask the x and the y component. Are we clear?
Yes, sir.
भाई समझ भी आ रहा है या ऐसे ही ये सर करते जा रहे हैं?
No, sir.
समझ आ रहा है ना? हाँ, समझ आ रहा है ना?
Yes, sir. Yes, sir.
कोई भी डाउट है तो रोक लो. तो this 100
Yes, sir.
Newton, I hope now it is clear That's its x component. One second. Now we understand that this 100 Newton can be resolved into x-axis and y-axis. Sorry, x-axis and y-axis like this. Is it making
Yes,
sense?
sir.
Where this would be 86.6 Newton. This would be the x component of force, and this would be 50 Newton. This would be the y component of the force. Chris, is it making sense?
Yes, sir.
And I can add the two vectors, x and y component, to have the original force component again. Is it making sense?
Yes, sir.
Okay. Now what you need to do is, using the logic that we have understood, try to resolve this velocity vector into x and y component. Would you be able to do now?
Yes, sir.
Yeah.
Yes.
Try to do.